Alright, so here is the whole point of what we're doing. It's called linear programming. This is out of context, but this is all the stuff put together in one. So, let's see how we get there from here. First, what we're going to do is graph our line. Y is less than 4, so we shade everything below, and I just use a little bit of shading. I don't shade the whole graph. Next, to do the next line, y-intercept is 6, -1 slope, looks like that. I got to test the point. So the point I'm going to test is going to be 0, 0, since it's not on my line. I test it, it works, so I include 0, 0 in my line, so I shade that side of the graph. Okay, didn't want that to show up. Alright, so next I got to graph the next line. Now, the numbers aren't really great on here, so I got a y-intercept of -3/2, and then, so that's -1.5, and I got to go up 1 over 2 from there. Alright, so that kind of stinks. But think about it. That point on the grid line is halfway between those 2 points. So that must be on my line as well, because it's exactly halfway vertically and horizontally. Therefore, I can include that line, point. And if I go up 1 over 2 from that point, that then gives me another point on the grid, and it's going to be a lot easier to continue that pattern. I then test a point. That works out, so I include 0, 0, so I shade this side of the line, again with just those little tick marks. Next line, and notice that because I continued the pattern, that was a key idea, that because I continued the pattern through all the dots, what that does is that allows me to really identify what the points are. So I can see that this cross is on a grid line. I can tell what the XY points are. I can tell what the XY point of that intersection is. I can tell the XY point of that intersection and the XY point of that intersection. So that's really key, because that's the next thing that we're going to do with all this. So I do my last testing of 0, 0, I do my shading, and then the final resultant region is right here. Everything in there is called my feasible region. Now I'll explain why we call it the feasible region once we do some applications, but you need to know that you need to be able to find all the corners of the feasible region, and then we're going to plug them into that max-min function right here. Alright, so now we want to find the maximum and minimum. It said on the previous slide that the max-min function was 3x plus 2y. So what we do is we identify each of the coordinates of our, each of the points on the corners. Jeez, talked Dave here. And there's a theorem that says that the maximum minimum value, so if we were to plug in any value anywhere in this region here, any value, we're going to get a different value for this function. Why isn't that writing? There we go. So we'll get a different value for this function for any of the different points we plug in here, but the maximum and minimum will always occur at one of the corner points of our region. So what we need to do is identify all the corner points of our region and then plug them into that function. So the first one is 0, 4. We plug it into the fxy function, so we plug 0 in for, identify all the corners. So it's 2, 0, 2, 4, 1, 5, 1, and then the last one down here is -1, 2. So for each point, we plug it into the max-min function. So for the first one, we plug in 0 for x and 4 for y, and we get an 8 as our final answer. Plug in the next one, and we get a 14. Plug in the remaining ones, we get 17 and -7. So that tells us that our maximum value is going to be 17, and that's when x is 5 and y is 1. So this is where our max occurs, and then our minimum occurs at -1, -2. Our minimum value is -7 for the max-min function, also called the optimization function. So the actual value of our minimum is -7, and that occurs at this point when x is -1 and y is -2. Now, it's not always going to occur where x and y is the lowest. So this example is just sort of a generic one. But just because this is lowest on the graph does not mean that necessarily is our min, right? Because these 2 points are higher, and those aren't the maxes. It really, really depends on what this function is like. So just because these are negative, that doesn't mean it's going to give us our minimum either, necessarily. So you'd really have to use some common sense when we get into some more interesting problems. But there it is. That's linear programming.